Imagine standing deep inside one of the oldest surviving structures on Earth. No electricity, no modern machines, just the silence of thousands of tons of rock. Most people look at the Great Pyramid and see a solid mountain of stacked limestone, but the interior is far more complex. It contains a calculated network of passages, including the descending passage and the Grand Gallery, which features a remarkable core belt ceiling. These corridors lead to finished spaces like the King's Chamber, built from enormous granite blocks and housing a large sarcophagus. For a structure this massive, there are surprisingly few known internal rooms. This creates a physics problem. All that solid rock creates a downward pressure the known architecture shouldn't be able to survive. The sheer weight of the pyramid is staggering. Millions of individual stones are constantly pressing down toward the center of the structure. If builders simply stacked these stones over an empty room, the chambers would collapse under the weight. To solve this, they built relieving chambers, stacked granite layers, and a massive gabled roof that distributes the weight outward, protecting the chamber below. This engineering logic suggests that the builders weren't just stacking stones, they were managing internal stress. If such complex systems were required for one room, it follows that other voids may be integrated throughout the pyramid's mass to maintain structural stability. Because these spaces are structural, they are invisible from the outside. To find them, we had to find a way to see through solid rock. In 2017, an international team attempted to map the interior of the pyramid without drilling a single hole or moving a single stone. They used a technique called muon tomography, which relies on particles created when cosmic rays collide with Earth's atmosphere. These muons can travel through hundreds of meters of rock, but denser materials stop more of them. This chart shows that if a detector picks up more particles than expected, the material is less dense, revealing a void inside. Researchers pointed these cosmic ray detectors at the Great Pyramid to see if any unknown spaces were hiding in the gaps of the data. This effectively turned the world's heaviest monument into a transparent map, allowing us to identify exactly where the ancient architects chose to leave gaps in the stone. The results revealed a massive, previously unknown structure located directly above the Grand Gallery, now known as the ScanPyramids Big Void. Then, in 2023, another discovery was characterized, a hidden corridor 9 meters long located near the pyramid's northern face. While popular theories often jump to secret treasure, there is no archaeological evidence of gold or artifacts within these spaces. Instead, these voids align with the engineering we see in the King's Chamber. They appear to be functional spaces designed to relieve internal structural stress and ensure the pyramid's survival over thousands of years. The discovery of these voids demonstrates that the pyramid is an incredibly complex engineering project, built by people who mastered the management of internal weight and geometry. Because the pyramid was likely entered and robbed centuries ago, the hope of finding physical treasure is a distraction. The real achievement is the monument itself. An ancient civilization organized millions of stones. With such precision, the structure has survived over 4,500 years. The information we are recovering now is the actual treasure. It is our first real look at how deeply the builders understood the physics of pressure and structural loads. A moment of wonder. We are currently using 21st century particle physics to reverse engineer a project designed with stone and bronze tools. Every new void we map confirms that the ancient builders were solving structural problems we are only just beginning to identify, proving that the Great Pyramid still has a technical story to tell.